Here we go, Algebra 2. This video is for Unit 2, Lesson number 3. And we're looking at some of our special binomials. As we can see here, the first type of special binomial we're going to deal with is our difference of two squares. And of course, to have a difference of two squares, both terms in our binomial must be perfect squares, and of course, they must be separated by our subtraction sign. And we see the form, they always are going to factor out to that form right there. So whatever we have as our perfect square for A, we take the square root of that. Whatever is the perfect square for B, we take the square root of that, and we write it here as we can see in its factored form. So let's go ahead and take a look at this with our x squared minus 36. Well, the square root of x squared, of course, is x. And the square root of 36, well, I'm going to write it, let's write it like this. We have negative 6 is the square root of 36, but so is positive 6. And of course, the shorthand way we can write that is to say, we can just say positive, negative 6. And that tells anybody who has their knowledge of mathematics that you are talking about positive and negative 6. So we already see the format that our answer is going to be in. So I'm going to go ahead and put the answer in our parentheses here. And we have x there. X plus 6, x minus 6 is our answer there. And now looking at our next one, we have 225. What is the square root of 225? Well, the square root of 225, 15. And the square root of a squared, well, we saw the square root of x squared is x. The square root of a squared is a. And so we can write our answer. Now we've got 15. I'll put my minus first this time. 15 minus a. Of course, it does not matter because of our commutative property of multiplication, and 15 plus a. Now, we will run into some difference of perfect squares where our exponent is not a 2. But as long as our variable is an even number exponent, as we can see here in our notes, if it's an even number exponent, it's always going to be a perfect square. What we want to do is take that even number exponent, and its square root is when we do it. No, that's not what I want. There. We want to take that exponent and divide it by 2, and that is the square root of it. So we see this with this one right here. What is the square root of x to the 4th? Well, we take 4 and divide it by 2. So the square root of x to the 4th is x squared. And just to throw it in here, if we square x squared, of course, that is going to equal x to the 4th. Oh, no. Okay, and so we can go ahead and set up our parentheses for our answer. We have, well, we just saw that the square root of x to the 4th is x squared. The square root of 121, all right, that's why we filled in our table up at the top of our notes, x squared plus 11, x squared minus 11. And I'll go ahead and put a box around that. Now with these two, this next binomial, with these two terms, I want to show something here, because when we talk about the square root of a monomial, When we have a product there, a product underneath a radical, we can split apart that product so that each part of it, the multiplicand and the multiplier, gets its own radical. And that is an m, not an x. Oh no, got rid of too much of it. So we got the square root of 49 and the square root of m to the 6th power. Well, we know the square root of 49 is 7. The square root of m to the 6th power, well, what does it say in our notes? We're going to take that even number and divide it by 2. So we get 7m cubed. So now let's go ahead and write our answer. Should have done this before, but I like going ahead and setting up my parentheses because I know what my answer is going to look like. 1 minus and 1 plus. So we have 7m squared and 5m. 7m squared and 5m. So right about now, I'm going to put a box around that because that's my answer. And there we have it. That's how we do our difference, factoring our difference of two squares. Now let's take a look at our sum and difference of two cubes. And this is just a little bit more complex, a little bit more involved with this, or as I like to say, a whole lot more fun. So we need to look at these patterns. We've got to memorize these patterns, all right? There's no way around it. If you want to be successful with your factoring, your sum and difference of two cubes, you've got to learn these patterns here. But what I want to do before I get into these patterns is I want to show that this is the factored form of our difference of two cubes, and this is the factored form of our sum of two cubes. And the way we show that is with the distributive property. So as I said in our earlier lessons in this unit, if we factor a polynomial and then perform the distributive property on what we factored, we need to get back to our original polynomial. So let's look at this here. We want to start off looking at a minus b times a squared plus ab plus b squared. And now let us proceed with our distributive property. So we've got multiplying a times a squared. And we know that's going to equal a cubed. Then we're going to multiply a times ab. That is going to equal a squared b. And boom. And then we have a times b squared. And that's going to equal a b squared. Now we're going to repeat that process with our second term with b, or actually negative b. So we have negative b times a squared. That, of course, equals negative a squared b. Whenever we have more than one variable in a monomial, always like to put it in alphabetical order. Then we have negative b times ab. That gives us negative ab squared. And then negative b times b squared equals negative b cubed. Now what we're going to do is write all of this out. All of these separate monomials we have here. We have a cubed. Then we have a positive a squared b, a positive ab squared, and then minus a squared b, minus AB squared minus B cubed. Now let's combine our like terms. So we've got, well, let me go back to that color. We have A cubed. We have a positive A squared B, and we have a negative A squared B. So boom and boom, they knock each other out. They sum to 0. We have a positive AB squared, and we have a negative AB squared. And so boom, boom, they knock each other out. They sum to 0. And then we're left with, well, what are we left with? We're left with that negative B cubed. So we see that, yes, indeed, if we factor out A minus B times A squared plus AB plus B squared, that does equal A cubed minus B cubed. So we're good with that one. Now let's go ahead and do the same thing. Over here we have A plus B times A squared minus AB plus B squared. And you know what? Who couldn't use a little bit more practice with our distributive property and multiplying our polynomials? So this time I'm going to switch my colors. We're going to go ahead. We have A times A squared. Again, it's going to equal A cubed. A times negative AB is going to equal negative A squared B. And then A times B squared equals AB squared. Do the same thing, but this time with positive B, B times A squared. Yeah, that's the best B I've done so far. That equals A squared B. Then we have B times negative AB, negative AB squared, and then B times B squared equals B cubed. So let's write our answer. Let's write our product, our total product. I'm not going to write it all out like I did with the first one, but we know we're starting off, we have that A cubed, we have a negative A squared B and a positive A squared B. So again, those two knock each other out, sum to 0. We have a positive AB squared and a negative AB squared. Well, we know what happens with those two. And then that leaves us with that positive B cubed. So we have shown that these are the two factoring patterns that we get, or the two patterns we get when we factor our difference of two cubes and our sum of two cubes. And we have this acronym here to help us remember the pattern. All right, well, we see with our first binomial, that sign is going to be the same. All right, so take a look at that there. When we start our first binomial, or when we start a binomial, that sign is the same. So these signs are the same. And then the next sign that we come across is always the opposite of that first sign, or we could say it's always the opposite of the sign in the perfect cube binomial that we start off with. And then in front of our B squared, that is always positive. So same, opposite, always positive. So a little acronym to help us with our factoring sum and difference of two cubes. All right, so let's go ahead, bring this down. Now, exponents that are multiples of what are perfect cubes? Kind of easy to figure out what goes right there. Exponents that are multiples of 3 are perfect cubes. Now let's put this into action and factor these right here. So we have A is a, I want to write it out like this. We have the cube root of a cubed, of course, equals a. All right, because like right here, those cube root and cubing, those are inverse opposite operations of one another. And then the cube root of 1, of course, is 1. So looking at our pattern, I want to bring it up so we can see. Well, you'll be able to see the pattern on your paper. Okay, so we've got A is A, and 1, well, no, do it this way. B is 1. So when we fill in our pattern, it's the sum of two perfect cubes. So our first sign is going to be the same. We're going to have A plus 1. Then we're going to have A squared. And our next sign is going to be opposite, so we're going to have minus. And then A times B, well, A times 1 is just A. And then always positive, B squared, 1 squared is 1. And there we have the factored form of it. And what I'm going to do here, I'm going to cheat just a little bit, putting a box around my answer. Cheating is not good. But in this case, doesn't matter. All right, now let's look at our next one. We have, well, I'm not going to write out that the cube root of c cubed is c, but I do want to go ahead and put that the cube root of 27 is 3. So now in the place of A, we're going to put C, and in place of B, we're going to put 3. So we have the difference of 2 cubes, so we're going to start off same sign. I don't like that C. Much better. C minus 3, all right, A minus B, same sign, and then we have A squared, or in this case, C squared. Then we've got the opposite sign, so we're going to put plus. And now A times B is C times 3, and of course we put our integer first. And then we have always positive, so plus, and B squared, 3 squared is 9. All right, hopefully you're getting the hang of it now. Cube root of 64. Again, we need to know our cube roots. 64 being a perfect cube and a perfect square. Cube root of 64, 3. Oh, what am I doing? 4. Had 3 on my mind there. Okay, we're back to a sum of 2 cubes. And now we've got 4 is going to go in place of B, so we have x, same sign, plus 4. And now our A is x, so x squared. Opposite sign, minus A times B is 4 times x. And then always positive, plus B squared, 4 squared, we get 16. And get a box around that. All right, our last one. Okay, a couple things I want to show with this one. Just like with our square roots, we're going to do the same thing with our cube root. We've got the cube root of 8z to the 6. Again, that's a product. So we want to take out, we got the cube root of 8. That's going to be our A. And the cube root of z to the 6th. So, of course, we're going to divide 6 divided by 3. So that's going to be z squared. The cube root of z to the 6th is z squared. Now, hopefully I can fit my answer in here. Okay, so now we've got A. We know A is going to be 5. A plus B, so 5 plus 2z squared. go ahead and squeeze that in there, 2z squared. I'm going to go ahead and squeeze in that the cube root of 8 is 2. So we have 5 plus 2z squared. I picked the wrong color. And then we have a squared, 5 squared, 25. Opposite sign, so minus. And now a times b is 5 times 2z squared. So that is 10z squared. And then always positive, plus b squared. So b squared is 4z to the 4th. And hey, let's get a box around that. And I want to show one other thing. We're going to talk more about our exponents later on. But with that b squared, I want to make sure I show, we said b was 2z squared. And we want to square that. So when we square that, we've got to square each part of the monomial. And that is how we get our 4z to the 4th. Okay, and that is our video for this lesson. We're done.